Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of cloud computing. We'll dive into key concepts like utility computing, elastic computing, Ajax, asynchronous, rich interfaces. Let's get started. Slide 1. Utility computing. Let's begin with utility computing, a concept that mirrors how we consume utilities like electricity or water. The idea is to treat computing resources, such as storage, processing power, or software, as a service. You pay only for what you use, making this approach highly cost-effective. On-demand resources mean there's no need to invest heavily in infrastructure upfront. For example, instead of buying expensive servers, you rent processing power during peak demand. The pay-as-you-go model ensures that costs align with actual usage, making it suitable for startups and enterprises alike. This model thrives on shared infrastructure, where multiple users share physical resources. Imagine co-working spaces where multiple individuals use shared facilities. Similarly, in utility computing, shared infrastructure reduces costs while ensuring performance through scalability. Automated provisioning is another highlight. Resources are adjusted dynamically without manual intervention. Think of how Netflix handles sudden increases in users during popular shows by allocating more servers automatically. This concept is particularly useful for businesses aiming to stay agile and efficient. By eliminating upfront costs and maintenance headaches, utility computing allows companies to focus on innovation rather than infrastructure. Slide 2. Advantages of utility computing. Next, let's discuss the advantages of utility computing. 1. Cost effectiveness. Imagine a business that no longer needs to invest in servers or software licenses. Instead, it rents resources based on demand. 2. Scalability. Whether handling a sudden traffic spike or scaling down during off hours, utility computing provides the flexibility to match demand. 3. Flexibility. From testing new applications to running production workloads, it supports diverse requirements. 4. Ease of use. Automated tools streamline tasks like deployment and scaling, reducing the need for extensive technical expertise. 5. Global accessibility. Resources can be accessed anytime, anywhere, enhancing productivity for remote teams. 6. Reduced maintenance. Since the provider manages hardware and updates, the user saves time and effort. 7. Disaster recovery. Built-in redundancy means data is safe even in the event of hardware failure. Each of these points highlights how utility computing can simplify operations while lowering costs and risks. Slide 3. Elastic computing. Elastic computing is closely related to utility computing but focuses more on dynamically adjusting resources to meet real-time demands. Let's say an online store sees a surge in visitors during a holiday sale. Elastic computing ensures that additional servers are allocated automatically to handle this traffic. Similarly, once the traffic subsides, the resources are scaled down, saving costs. This dynamic nature makes it perfect for businesses with fluctuating workloads. Elastic computing is implemented primarily in cloud environments, where tools like AWS autoscaling or Azure scale sets enable real-time adjustments. The emphasis on automation reduces human intervention, ensuring resources are allocated as needed. Slide 4. Advantages of elastic computing. The advantages of elastic computing include: 1. Performance optimization. Resources scale up during peak loads, ensuring uninterrupted user experience. 2. Cost savings. You only pay for the resources consumed. During off-peak hours, costs decrease automatically. 3. Flexibility. Businesses can experiment with new workloads or applications without worrying about resource constraints. 4. Reliability. High availability ensures that services remain operational even during resource adjustments. 5. Efficient resource utilization. Prevents over-provisioning, minimizing waste. 6. Reduced downtime. Automated scaling mechanisms address resource needs before they cause service interruptions. 7. Environmental impact. By using resources efficiently, elastic computing contributes to greener IT practices. Slide 5. Ajax, asynchronous JavaScript and XML. Ajax revolutionized web development by enabling asynchronous communication between the client and server. This means that only the required parts of a web page are updated, avoiding the need to reload the entire page. For instance, when you type in a search bar and suggestions appear immediately, that's Ajax in action. It uses a combination of HTML, CSS, and JavaScript for the front end and XML or JSON for server communication. One key benefit of Ajax is its ability to create a dynamic user experience. Features like auto-suggest, live feeds, and real-time notifications rely on this technology. By reducing the data sent back and forth between client and server, Ajax minimizes server load and improves performance. Slide 6. Advantages of Ajax. Here are the advantages of using Ajax. 1. Improved user experience. By avoiding full-page reloads, Ajax creates smooth, responsive interfaces. 2. Faster load times. Only the necessary data is fetched, speeding up the application. 3. Reduced bandwidth usage. Ajax sends smaller packets of data, saving network resources. 4. Cross-platform compatibility. Works seamlessly across various devices and browser. 5. Interactive features. Real-time search or notifications are made possible with Ajax. 6. Simplifies development. Developers can create feature-rich applications without heavy server processing. 7. Extensibility. Ajax integrates well with modern frameworks, enhancing its utility. Slide 7. Asynchronous rich interfaces. Asynchronous rich interfaces build on Ajax to offer even more dynamic and interactive user experiences. These interfaces allow non-blocking operations, enabling users to perform multiple tasks simultaneously without interruptions. For instance, features like drag-and-drop functionality, live editing, and animations are examples of rich interfaces. They often rely on modern frameworks like React or Angular, which offer tools for creating fluid and responsive designs. One critical feature is data binding, where changes in data are reflected immediately in the user interface, enhancing usability. Asynchronous rich interfaces make applications feel more like desktop software, ensuring user satisfaction. Slide 8. Benefits of asynchronous rich interfaces. The benefits include 1. Improved productivity. Faster interactions mean users can accomplish tasks more efficiently. 2. Real-time updates. Applications like social media feeds or collaborative tools update instantly. 3. Enhanced visual appeal. Supports modern design elements like animations and transitions. 4. User-centric design. Interfaces adapt dynamically to user behavior. 5. Lower latency. Eliminates delays caused by server requests. 6. Efficient resource usage. Prevents unnecessary page reloads, saving both time and bandwidth. 7. Ease of integration. Works seamlessly with backend systems and APIs to provide advanced functionality. Slide 9. Differences, Ajax versus asynchronous rich interfaces. Let's quickly compare Ajax and asynchronous rich interfaces. Ajax focuses on simplifying server communication, using traditional technologies like HTML and JavaScript. It is ideal for basic tasks like form validation or live search. Asynchronous rich interfaces go a step further by leveraging advanced frameworks like React or Angular. These interfaces are better suited for creating single-page applications, where user interaction needs to be dynamic and seamless. While Ajax is easier to implement, asynchronous rich interfaces offer higher performance and greater flexibility. The choice between the two depends on the complexity of the application. Slide 10. Limitations of asynchronous rich interfaces. Finally, let's discuss the limitations. 1. Complex development. Asynchronous rich interfaces often require expertise in multiple technologies, increasing development complexity. 2. Browser compatibility. Older browser may struggle to support advanced features. 3. Security risks. Features like dynamic scripting can expose applications to vulnerabilities like cross-site scripting, XSS. 4. Higher resource usage. These interfaces demand more from client-side systems, impacting performance on low-end devices. 5. Debugging challenges. Identifying issues in highly dynamic environments is more complex. 6. Learning curve. Developers need time to master frameworks like React or Angular. 7. Dependency on Java. If JavaScript is disabled, the interface may fail to function.